Hey guys, I just went live for COMPSCI 1MD3, tutorial number 8. We'll be starting at 8:30 once again, so you have a few minutes to get ready. And in the meanwhile, I will make my regularly scheduled Avenue post. So let me copy this link. Cool. And I will make my Avenue post in the meantime until 8:30. So I'm just navigating to Avenue to make the regularly scheduled post. And in the meanwhile, you guys can sit back and relax until 8:30. Up until then. Cool. So we're on tutorial number 8. There are 4 left, just 2 more weeks, and then we're all done. And we can enjoy the rest of our summer. I'm excited. Copy this. Copy key not working. That's going to be frustrating. There we go. And I will copy the slides too. And we'll be ready to go in just a few minutes. I don't like this formatting. Cool. And we'll be starting in 1 minute. In 1 minute, we will be going live for the tutorial this week, for this Monday, number 8. And today is pretty useful stuff, pretty relevant content. We'll be going over how to make a class in Python and the essence of object-oriented programming. So this is probably one of, I'd say, the most important concepts we go over in class. I'd say this, trees, and recursion are probably the 3 main concepts that students have a bit of difficulty understanding. So hopefully you find the content in this tutorial to be useful and to supplement your understanding. And if not, our inboxes are always open. So that being said, in today's lesson, we'll be going over classes. So just out of curiosity, does anybody know what a class is? And because this is an online lecture, that's a rhetorical question. But yeah, so essentially we're going over what a class is in Python or just in any coding language. And a class is essentially a blueprint for creating a particular custom data structure. Instead of storing our data in a general data structure, imagine lists, dictionaries, tuples, so on, we're going to create a general data structure or class that is best for the data that we're trying to store. So we're going to make our own custom data structure instead of using one of the already pre-existing data structures like a string of the string class. So before we go into today's coding challenge, let me do a practice example of how to make a class with you. So I'm going to open up Python, and I'm going to change my options to make sure the text is nice and big. Cool. And I'm going to make a new Python program, and I'll save it accordingly in a folder for this week. And I will make sure the syntax is, or the convention is the same. There we go. Cool. And I'm going to make a new Python program, and I'll call this program anything. I'll call it car. Cool. And what I'm going to do is I'm going to make a car class, a general car object that I can replicate over and over again as different objects in Python. So in order to make any class, all you do first is type a class into Python. And as you can see, it highlights, and that's because it's a keyword in Python. And then I'm going to define the name of my class. Now, as I said before, we're going to make a car class. So I'll call it car. And generally, the Python convention is when you're making a class, unlike with making a function, the first letter should be capitalized. Now, that's not mandatory, but it is convention. And when I make a class, the first function that I need to define is called the init function. So I'm going to write def to make a new function, then double underscore init, I-N-I-T, and 2 more underscores. There you go. Followed by a few sets of brackets and then colon. And inside the init function, I'm going to pass in all of the parameters of the car. So I'm going to define these parameters as I see fit. I'll call them self, color, seats, miles. So the one variable that you might not be familiar with is called self. Now, self is a mandatory variable that you have to include whenever you define a new init function. So always make sure to include self. And self allows us to reference the actual object itself. It's kind of like well, not much like it, to be honest, but if you guys know JavaScript, it is kind of like this keyword, but not totally like it. Okay, so I'm then going to define the values of the car object. So all I'm going to do is I'm going to write self.color is equal to color. So I'm saying that this object that I'm constructing in the init function has a property known as .color, and that's equal to the color value that I'm going to pass in. I'm then going to define self.seats, and that's equal to seats. And likewise, finally, self.miles is equal to miles. Awesome. There we go. Now, this function I've made right here is known as a constructor. That's a term that is universal across coding languages, and it describes the function of the class that actually constructs an instance of that class. In my constructor, I define all of the properties of each car object. What are those properties? They're color, seats, miles, and they are all equal to the values passed into the constructor. Okay, so now let's instantiate our class. So to instantiate our class, all I have to do is exit my class, and I'm exiting the class because I'm no longer tabbed. Any code that is tabbed is within the class itself. And I'm going to define a new variable. Let's call it car1. It's the first car that we're defining. And I'm going to say it's equal to the car class. So I can initialize, or I can instantiate, create a car object by just typing car. That's the name of the class. And when that happens, car is automatically going to reference the init function in order to make a new car object. And when it references the init function, it needs all of the parameters specified by init. And those parameters are self, color, seat, miles. So self, it gets automatically. Color, seat, and miles, I have to pass in. Okay, so let's pass in some random properties for our car. So let's say the color of the car is green. Let's say it has 5 seats. Oh, seats. And let's say it has like 50,000 miles, okay? So now I've created a car object. I've created an instance of the car class. The name of that object is car_1. Cool. And I can actually, I can demonstrate this object. So if I typed print car_1, what do you think is going to be printed out? Let's run this code. Yeah, and so Python just prints out the object name, the unique ID that is generated whenever a new object is made. So whenever you make a new object in Python, a unique ID is generated. But I can access the specific properties of the car too. And I can do that by typing dot and then the property name. So remember that according to my init function, the car has 3 properties: color, seats, and miles. So I can type dot color, and that's going to return the color value, which is green. Okay, let's run that code. Cool. And so some syntax to keep in mind is that because this is a, we're calling a property, not a method, there's no brackets on the end. A bracket signifies a function or method that you've defined in the class. No brackets means you're calling a property. Oh, by the way, any function written inside of a class is referred to as the method of that class. Some terminology for you. Cool. Okay, awesome. All right. So I'll leave this up on the screen for a minute, and you can just replicate it if need be, and then I'll add some more methods to my class. And we can play around with it a bit more. Okay, so something I want to demonstrate is that every time I instantiate the class, or I'm creating an object of that class, I'm creating a unique object, right? So let's suppose I copy my car_1 value and I call it again. So now I've created 2 car objects, car1 and car2, and they both have the same properties. When I run my code and I print out the IDs, you'll notice that they are different. That's because every object generated is unique. It has a unique ID. Cool. Now keep in mind, I can access all of the properties of the car object by, of course, using the dot system, where I just type dot and then the method name. And Python is so smart that it's going to automatically cause a dialog box to pop up with all of the property names. So I can have dot color, and I can print out dot seats, and I can print out dot miles. Cool. And I can say color is relative to color for car1. My apologies. Color for car1 is so-and-so. And I'll just edit my print statement to make this a bit more intuitive. Cool. Color, seats, miles, cool. And I'll do the same thing for car2. And I'll give them both some unique properties just to exemplify how I can access properties of my car. And now I can run my code. Okay, cool. And as you can see, I'm able to access all of the properties of my car objects, that they're green and blue and have 50,000 and 70,000 miles respectively, by just using the dot parameter. Now this is why the self function must be passed, sorry, the self parameter must be passed in the init function, because self is what allows the object to refer to itself. Without the self parameter, we would not be able to refer to the object itself. Cool, okay. All right, so I've made a basic class, and that class has one method, the constructor method, to in order to make or instantiate the objects of the class, which I've exemplified here. Awesome. Now, at this point, you might be wondering what's the point of this whole abstract concept of classes and object-oriented programming. Well, it's just an easier way to store data. Right now in this course, whenever we've tried to store series of data, we'd probably store them in a list or a CSV file or text file or something. Like if I had 50,000 cars, I'd probably, given the knowledge we have so far in this course, represent all that data using like just the columns of a CSV, which is totally fine. However, you may realize that that method doesn't scale that well. It becomes a lot more convenient to make your own data structures that are customized to work with the exact code that you're making. So this is known as object-oriented programming once again, and it really is one of the cornerstones of coding. Okay, so right now we only have one method in our class, the constructor method. However, I can add more methods as need be. Now let's suppose we need to add to the number of miles on each car. So the car starts off with a certain number of miles, but then if you start driving that car and you're storing all of this data in some database or something, you would need to update the entered amount of miles for that car. So how can we do that? Let's just exemplify this. Let's suppose I have just one car object. Make this a bit less messy. Remove the unnecessary lines. So I have one car object, car one, and when I run it, you can see that car one has 50,000 miles. Now I can change the number of miles that car one has by just typing car_1 dot miles. I can refer to that property specifically, and I can make it equal to some new value. I can say it's now 80,000. Okay, and if I print out the value once again, you'll see that initially, you'll see that initially the number of miles for car one is 50,000. But then after I add, or after I modify the miles property to 80,000, the number of miles for car one is 80,000. Okay, not too bad. So that's one way to modify the property values of a car. That's also the janky way. That's not the best way to do that. Instead, we should use something called a Mutator method in order to change the number of miles. So how do we do that? Well, we can make a new method in our class to add to or modify the number of miles. Like let's say, for example, right now in my code, I have currently the car has 50,000 miles and I want to raise that to 80,000. I would normally, using the knowledge we have, just write plus equals 30,000. And you know what? That code would work just fine, but it's not the proper way to do things. Instead, the proper way is by making a Mutator method. So how that would look like is I would go back into my class and I would define a new function, def, and let's call it add miles. And this method is going to have two parameters. Because it's in a class, one of the parameters will be self, and another parameter will be new miles. So we're going to have a method called add miles, and this method is going to take some car object, and it's going to add some new amount of miles to the total miles of that car. And so, how that method would look like is very simple. It's just going to be a mutator method, which means I'm going to modify the object directly. So I have my object self, and I'm going to say its property value miles plus equals new miles. Cool. So you should only really be calling the properties of a class within the class itself. It's bad form to call the property outside of the class. Instead, I should use a mutator method or accessor method to refer to those properties. Okay, so let's suppose I want to, I'll keep both lines in actually. So I have this way of modifying dot miles, and it's totally going to change the number of miles. Cool, and it's totally going to change the number of miles. What I can also do is I can say car underscore one dot add miles, and I can pass in the property. So itself is taken automatically as the parameter before dot, and the other property I have to pass in is new miles. So let's say I want to add 20,000 miles for a total of 90,000. Or no, for 100,000, my bad. So 50,000, 30,000, 20,000. Cool. And as you can see, once again, the total number of miles is added to. Okay, let's run this code. Oh, did I not? Oh, my bad. And Python is case sensitive, so you have to make sure to follow the capitalization. And another Python convention, in the same way that there's a convention of having variables be separated by underscore. For function, the convention is camel case, so the first letter is lowercase for the first word, and for every subsequent word, the first letter is uppercase. And finally, for class, the convention is that the first letter is uppercase. Okay, so you run the code. Cool. And as you can see, you're modifying the property miles by both calling that property directly, which is the bad form, but still works, or you can add to the total number of miles with the mutator method. So this type of function, or method, that modifies the property directly or modifies an object directly is known as a mutator method. Modifies object directly. Cool. Okay. Let's make a few more methods for this class. Now, in the same way that it's wrong to call properties outside the class, you also shouldn't call them if you need to print them out. Instead, you should use something called an accessor method in your class. An accessor method just returns the property of a class. So for example, I can say def, and then generally accessor methods start with get. I can say def from get color, and I can have one property, and that's self. Okay. One. And I can just say return self.color. And now if I want to print out the color, so the color for car one is I can say instead of saying car_1 dot color, I can instead say car_1 dot get color. There we go, with brackets. So once again, this is the bad form that still works. And this is the proper form. Cool. So let's run the code just to verify it works. And as you can see, both of the forms do work, but this is the better form. Okay, so I'm going to finish making this class, and I'm just going to make an accessor method for the remaining two functions, or two properties. Or actually, how about you guys try that out? So we'll do it simultaneously just to save. Or actually, no, we have time. I've changed my mind so many times, sorry. So yeah, just how about I pause for 2 minutes, and you can finish making the two remaining accessor methods. So I'll just right here, please finish the class, make the two remaining accessor methods. Okay, so this is known as an accessor method once again. And it's called an accessor method because we're only accessing properties of the object. You're not changing or modifying the properties directly. So accessors and mutators. Okay, so I'll pause until 8:55, and you guys can work on that. So I'll say pause until 8:55. All right, so I'll be back in 2 minutes. Or I'll still be here, but you guys can try that out. Awesome. These are going to be a long 2 minutes. 1 minute left. Okay. So after 1 minute, I will finish up the code and make the remaining two accessor methods. And then we will do today's coding challenge. And I guess while I'm paused, I just want to reiterate the purpose of the class concept in Python. So right now we are trying to make these car objects to store the properties of a bunch of cars. If I did not use classes, imagine how you would make this or store this data in Python. Think about it. Without a class, without this class concept, how do you store the properties of these cars in Python? I imagine most of you are thinking of previous built-in data structures like lists, tuples, dictionaries, or perhaps reading in a file that contains all that data. So just making your own class is just a cleaner way to store that data, as opposed to using the built-in data structures. Now, the data structure that you use, it can contain those other built-in data structures. So for example, I can set a property equal to a list or int or a string, or in this case, they're all set to ints already. Okay, so I'm going to finish making this, this class. I'm going to make the two remaining accessor methods. So once again, the convention for an accessor method is to write get, followed by the property name that we're getting. So we have two left to get. We have seats. And the only parameter we're passing in is self. That allows, once again, the object to refer to itself. And I can return self.seats. And I can use the exact same concept to make the last accessor. I'm going to get miles. Self.miles. How about I call all of our methods in down here just to verify that the code is working as intended. Okay. So here I'm making the object. Here I am adding to it. Cool. And I can just have one print statement that gives all the properties. So I can say for car 1, the color is, and then I can refer to my color accessor method. And then I can say the number of seats are. Once again, I can refer to my accessor method by writing the object name, that's car_1, dot get seats. And Python is so smart that it should, for some reason, get seats isn't showing up, but generally it should automatically come up. So get seats. Let's spell it right. Yeah, get seats. Okay, well, it's weird. Okay, and then the number of miles are car_1 dot get miles. Cool. Okay, and then let's run this code. Cool. And as you can see, it prints out all the properties, the color green, the number of seats, and the miles. And keep in mind that the miles we mutated with our mutator method add miles. Okay, so this is a basic class made in Python, a car class. So just rough clip notes, the syntax to make a class is class, we're adding class followed by the class name. And generally, the class name should be capitalized. And the only other function you need in the class or method that you need in the class is the constructor, or that's the init method, which looks like this, which is where you define all the properties of each object of that class. And yeah, functions inside of a class are known as methods in Python. Cool. Okay, let's go to today's question. Okay, so how long should this take? All right, let's say that I pause until 9:05 and you guys can try to complete this problem. So in this challenge, we have to make a new class called student. And that each object of the student class has 3 properties. The name, which is a string, the age, which is an int, and the GPA, which is a float. All right, you can get this slide on the Avenue page, by the way. And then we also have to define the following methods for the class. So we have 3 accessor methods: get name, get age, get GPA, which return just those values, name, age, GPA. And then we have to make 2 other methods, is smarter and is older, which return a Boolean true or false if the student is smarter or older than another student. And according to this class, intelligence is measured by GPA, but I'm sure a GPA is not, I'm sure your GPA is not indicative of your intelligence, unless, of course, you have a high GPA, in which congratulations. All right, so I'm going to pause until 9:05, and I'll give you guys 5 minutes to attempt this problem by yourself. All right, so let's put that in the corner. Cool. So I'm going to pause for 5 minutes, and you guys can try out this question by yourself. Cool. Okay, so why don't you try that out? And then we'll come back and we will finish off the class together. All right? So, Yeah, for my job, actually, I have to learn C++. So I'm relearning all the syntax in C++, and it's so much easier in Python. So I really wish I was still doing Python predominantly. Okay, so I will be coming back at 9:05. I'm still here, but you have until 9:05 to get this done. So you said yes, Amit, sorry. Okay. Did I miss a comment or something? I'm not sure what that yes means. All right. If you have a question, Amit, you can email me or you can ask in the comment section. But I'm not too sure what you mean. We'll be chilling in the meantime for 2 more minutes, and then I will show you how to make this class, and then I will import that class into Python, and then it'll work out. And we should be good to go. Okay, 2 minutes left. 2 minutes, and then we will take up this problem. And then we only have 3 more after this, and I'm so excited to have Mondays and Wednesdays off again. Monday, Wednesday nights. And I will run the auto grader on Tuesday. And the auto emailer is working now, thankfully. So that feedback should be emailed automatically. And I don't need to, hopefully, email anyone personally. And then I will buy all the MSAFs that I got from Nick once I run the auto emailer, and that'll all happen Tuesday night, probably. Cool. Okay, 1 minute left, and then I will take up how to make the student class in Python. Cool. Okay, let us make this class. It's not that bad. Cool. All right. Okay. So I'm going to start writing my code. The split screen. Cool. Okay. And I'm going to make a new Python program for this class, and I will save this as student. And yeah, sorry, another convention is when you make a class or module, or not, sorry, when you make a class, my apologies, you generally name that class with a capital in the Python file too. So here I'm making a new class called student, and the first thing I have to do is define my class. So how is the first line, the header of the class, going to look like? I'm going to write def, followed by the class name, which is student, and then a colon. All right. Okay, and then step 2 is what? I have to make the constructor, or the init method of the class. So I'm going to write def __init __, and then I pass the parameters in between the brackets. Okay, what are the parameters we have? Well, because it's a class and it's an init method, one of the parameters will be self, and then the parameter name, the parameter age, and the parameter GPA. Cool. Okay, and then I can just set the properties of my student object in the constructor. So I can say self dot, and I can define a new property. Let's call it name is equal to name. Likewise, self dot age is equal to age, and finally self dot GPA is equal to GPA. All right. So as you can see, I have my constructor for student with these three properties. For every single student object in the student class, we'll have these three properties, name, age, GPA, and they are set equal to the properties passed in to the class. Cool. Awesome. All right, so now it asks us next to make the getters or the accessor methods. So once again, similar idea. I can write def and then the function name, which is get name for one of them, and all the accessor method has to do is return the associated property. So the get name method should return self.getName. Or should return self.name. Self.name. There we go. All right. Okay, then likewise, def get age. All that does is return self.age. Oh, but I made a mistake. Does anybody see my mistake? So in addition to the constructor method, the get methods also have to have the self parameter, or else we can't refer to self in the method. Okay. And the final getter method is def get GPA. And self returns self.GPA. Cool. All right. Here. And you know what? Actually, I'll talk about that later. Okay, so let's try running this code. So let's try to instantiate a student. I'll call the student Soile. Soile. And I'll say Soile is an instance of the student class. So I can write student. Then I can pass in the parameters. So actually, I should call the student S1, and then the parameters I can pass in would be the name, which is Soile, and then I can pass in the age, and I'm 21, and then I can pass in my GPA, which is a 1. That's actually high. It's actually a 0.5 or a -1. Okay, cool. And then I can make another student. Oh, did someone comment? I'll make it the name of the student that commented. Okay, so Ahmet. So I can say that's the second student, Ahmet. And Ahmet, this is COMPSCI 1MD3. I'll assume that he's 18. And I'm sure he has a 12.0 GPA, very high GPA. Cool. And now I have these properties defined. And I can ensure that my getters are working correctly, or I can verify that my object was made correctly with the getters. So I can print out S1 dot get name, S1 dot get age, and then S1 dot get GPA. And this will print out the same properties that we defined in the object up here, right? Def. Oh, I'm sorry. Yeah, so for the header, the first line of the class, the syntax is not def student, it's class student. My apologies. Cool. And as you can see, he printed our values. We have S1, S2. And so here I'm printing out the properties of the first student. And S2 is the second student. And print out his properties too. And I can run that code. And we have demonstrated that we've successfully stored the data in our Python data structure that we made ourselves, our custom data structure or class. All right. So then we need to make two more methods. And those methods are is smarter. So that checks to see if one student is smarter than the other student. So I'm going to write def is smarter, and then the parameter I'm passing in is the other student, and I also have to pass in self because this is a method of the class, and it'll probably want to refer to the object that I am calling this method from. Okay, and all I have to return is whether the current student that we're looking at is smarter than some other student that we're passing in. So I can do that just by writing self.get GPA is greater than self dot, just greater than, right? Yeah, is greater than other student. And the other student is going to be of the student class as well. So I can call his GPA with the same method, get GPA. All right, and then I can test this code out. And so I can write a print statement to verify that my method is working. So I can say print. Print s1.getName. Actually, .getName is smarter than comma s1.getName. So this is going to say Amit is smarter than Swale, and then another comma, and I'll just pass in the is smarter function to verify that. So let's write s2 dot is smarter, and I'll pass in s1. Cool. Okay, let's run that code. So as you can see, our is smarter function is working. Okay, and finally, let's make an is older function. So once again, return true if student 1 is older than student 2. How does syntax make more sense? How about instead I write it is, and then comma, oh, other student will pop up. That's disappointing. Oh, S1. So it's going to say it is true or false that student 2 is smarter than student 1. Okay, let's run that code. There we go. Awesome. So our first, that method is working. Okay, let's make the next method. So I'm going to make the method is older. So def is older. And once again, you just are returning whether or not the age is greater. Very simple, and I can use a similar print statement to verify the functionality of that method. S2 is older. And this should say it is false, that the first student is older than the second student. Okay, let's run the code. Awesome. Oh, that space shouldn't be there. Oh, but I can use the plus key to get rid of the space. But I imagine you guys get that concept. Okay, cool. So I've made all the methods. There is one more set of methods we should have, and that set is known as the setter methods. So as I said, you should not be adjusting the properties of objects outside of the class. So like, for example, if I wanted to change someone's name, I wanted to say S1 dot name is now like, I don't know, Oasis or something. You shouldn't do that outside of the class. So instead, we should make a setter method to achieve that functionality. And it's very simple. I can just write def, set name, and once again, I have one parameter self, and then the second parameter, which would be the new name that we're passing in. And I can just say return, or actually, I can just say self.name is equal to name. Okay. So you don't need to have these parameters, but you generally do, just its proper form, to have like a setter method, a getter method. So once again, these were not included in the initial scope of the problem, but I just thought it would be a good demonstration to add them in. Okay, we have about 10 minutes left, so I think there's one more thing I should show you guys before I sign off today. All right, so we've made our class that has the constructor method. Then we've made the accessor methods. And then here is the mutator methods. And these are just like, logic, methods, just things, the operations to perform with the class. All right, so once you've made a custom class in Python, it might be so awesome and so cool that you might have to import that class into another Python program to use it and to reference it as need be. And we can do that using the exact same syntax we've been learning since earlier on in this course of the import statement, right? So if I have a new Python program, and if I save this program, if I save it in the same directory as my class, we'll call this main.py, I can actually import in that class. Right, and then I can run this code. And then, and as you can see, it's when I import in the class, it's running all the code in that class. We'll just comment that out. Now, if I go into the Python shell and type import student, it's going to import because I've ran the code previously. But if I open up a new shell, I say import students. Sorry, import student. It's still not going to work actually because Python doesn't know where the student class is. Now, for example, let's say I open up command prompt, and if I go to where my Python folder, Python class is set up. So where is that? It's not fun to use. This one better. Find the right place. Oh, sorry. This is not fun to use either. Hold on. Jeez. Man. My apologies. We'll be right up in a second here. Okay, so let's go to where my thing is located. So there we go. And then, what was it called? Perfect. Okay, awesome. So we go to work, and then we go to COMPSCI, and then we go to tutorial 8. There we go. And okay, and so for example, if I cd out of this directory, so I'm just in my general directory, and if I type Python to launch the Python shell from this directory, and I try to import in the student class, I get an error because Python cannot find this class in that directory. However, if I exit Python, and if I relaunch it from the directory where the class is set up, so that's tutorial 8, if I relaunch Python, I can now import in the student class perfectly. And I can actually instantiate the student object. So the syntax was like, let's say at S1, and that's equal to student. Let's screen this with, so S1, and that's equal to student. And then I pass my parameters, Swale, 21. Okay. Oh, wait. What did I do? Did I call the right class? That's weird. Okay. Sorry. That's odd. Oh, wait, I'm sorry. So then I can call an instance of the student class by typing s1 is equal to student dot student. I think that's it. And then I pass in Swale 21 1.0. Perfect. Yeah. So my apologies. So when you're calling it from outside the class, you have to reference the class you're calling because you could be importing in multiple classes, right? And then you can call the constructor method. My apologies about that. Now that's kind of tedious. So as you can see, I've successfully instantiated the class, and it has all of the right properties. But if it's tedious to refer to the class like that, instead, I can import in the class by saying from, I think it's capital F. So from Swale, import asterisk. And import asterisk means everything. So from, student, import asterisk. Okay, and let's run that. Oh, isn't it student? So from, let me try it here. Is it from keyword? Oh, it's not. Oh, my bad. Okay, once again, sorry. So from student, import asterisk. There we go. Yeah, perfect. Okay, so then this time, if I write S1 or S2 is equal to student, they can pass in some parameters. It's called just fine again. So in the first example, when I was importing a student as student, then I have to reference all of the parts of the student class with the dot parameter. However, if I import student by saying from student import asterisks, I can just refer directly to the methods. So that's how you can actually implement the class that you make. Okay, I think that's it for today. Let me just check to ensure there's nothing else. Awesome. All right, so yeah, I'm going to log off then if there are no other issues. And I'll wait until 6:27 if anyone has any questions. And if not, I'll be heading out and enjoying my night. Awesome. Okay, so I don't see any questions, so I'll be logging off. So, all right, take care. Have a good day, and I will be heading out. All right, bye.